Work. What is it? What do we need it for? How does it relate to energy? Today, we will discuss all this, and probably not more. First, what is work? Put simply, work is the transfer of energy that happens when an object is moved by an external force.
Wait, isn't work like doing a job?
Great question. No. Work has a few different definitions, but in physics, work is, as I said, the transfer of energy by an external force through displacement. So, no, me clocking into Panera every weekend isn't work, even though it definitely feels like it is. Anyways. Second, how do we find work? Work, thankfully, has one of the easiest formulas in physics. It's this, with the F standing for force and the D standing for displacement. Obviously. There is one more version of this, though, with the addition of cosine. This equation is used when a force is applied at an angle, such as pulling an object on the ground with a rope. Of course, when you calculate something, you need a unit for that. The unit for work is joules, written as just a J. A joule is defined as the work required to exert the force of 1 Newton through 1 meter. Now that we know what exactly work is and how to calculate it, where did work even come from? Work has always existed, just as forces and displacement have always existed. But the use of the word didn't appear until around 1826, when the French mathematician Gaspard Gustave Coriolis used it to mean, quote, weight lifted through a height. This was written describing steam engines, lifting buckets of water because, it was the 1800s. Other names that the concept of work has gone by throughout histories would be efficiency, moment of activity, dynamic effort, and even sometimes just force on its own. The unit for work, a joule, was named after James Prescott Joule, who was a 19th century English physicist. You may also know him for helping develop the law of the conservation of energy. Speaking of energy, let's discuss how work connects with energy. One of the biggest connections we can see is the actual definition of work, as well as the equation. In the definition of work, we can see it as being described as a transfer of energy, and a secret equation for work is just the change in energy. Energy is actually a measurement of the ability of something to do work. Kinetic, thermal, and potential energy are all acquired through different types of work, depending on the situation. We can even look at the work-energy theorem, which states that the net work done by the forces on an object equals the change in kinetic energy. This shows a direct relation between work and energy and is very easy to derive from the base equation of W equals Fd. Force is equal to mass times acceleration, and the displacement can be derived from the equation final velocity squared equals initial velocity squared plus 2 times acceleration times distance. Solving this equation for displacement, or distance, gives you d equals vf squared minus vi squared divided by 2a. And once this is inserted into the original work equation and everything is distributed, you get the equation shown, which is work equals the change in kinetic energy. Wow, okay, that was a lot. Let's switch it up a bit and look at an example of work in action, featuring Lucy. Everyone say hello, Lucy. For this example, we are going to be calculating the amount of work Lucy does every time she picks up a bone. First, we'll watch the situation in action. You sit. Now, let's examine the variables. For this situation, let's say the bone weighs 5 kilograms, and that Lucy lifts it half a meter up. So let's set up our equation. First, work equals force times displacement. Our displacement is half a meter, but what's our force? Well, taking the mass of the bone and multiplying it by 9.8, our constant for acceleration, we get what our force value is, which is 49 newtons. Once we multiply that by our displacement, we get the total amount of work done, which ends up being 24.5 joules. Good job, Lucy. That's a lot of work. Let's recap what we've learned. Work is defined as the transfer of energy that occurs when a force is applied to an object, causing it to move a specific displacement. The equation for work is force times displacement, as well as force times displacement times cosine of the angle of the force when applicable. Work has a direct tie to energy, as work itself is the change in energy, which can be displayed by the work energy theorem. And my dog is very cute. That's not really an important part of the video, but I thought you should know. Anyways, like, comment, and subscribe. Follow me for more cool physics. Wow, fun.